This video is intended to provide service professionals with supplemental training on the thermoscientific HM series of microtomes. Included in this training is a review of the basic operation of two of our top-selling rotary microtomes, the thermoscientific HM325 manual rotary microtome and the thermoscientific HM355S automatic rotary microtome. The service content includes a review of the thermoscientific Microtome specialty tools, procedures for cleaning and maintenance of working parts, and service tips direct from the manufacturer. In addition, we have incorporated applications content to assist the service technician in distinguishing between user-driven and instrument service-driven issues. We begin with a detailed look at instrument function. Before you can diagnose whether your rotary microtome is functioning correctly, there are a few cutting basics and issues, universal for all microtomes, to be explained. Cutting basics. Clearance angle is very important to the accuracy of section thickness on all sectioning equipment. The clearance angle is that between the knife edge bevel and the block. On the HM355S-3 microtome, the clearance angle scale is located on the left side of the blade holder. Each graduation is 2 degrees, and the longest line indicates 10 degrees. For thermoscientific Microtome microtomes, the initial clearance angle to begin with is 10 degrees. This scale is different from other competitor microtomes. If the clearance angle is too slight or too steep, thick and thin can occur. Thick-thin is a cutting deficiency where the end user will get a consistent thick section, then thin section, then thick section, and so forth, all in one ribbon, with the thickness varying between sections. As the unit ages and the blade clamping loosens, the clearance angle may need to be readjusted. Sometimes differences in the thickness of the disposable blade or the sharpness of the blade edge will also affect the ribboning. In these cases, the clearance angle will also need to be readjusted. Adequate cooling of the paraffin block is important to producing a good ribbon. Cooling the blocks on ice or a cold plate is preferred. Also, the type of paraffin used for embedding will affect ribboning. Typically, blocks made of softer paraffins will cut better, thicker sections in shorter ribbons, and harder paraffins will yield thinner sections and better serial ribboning. Cutting issues. The two most common cutting issues are thick-thin and compression. In both cases, the first thing to check is that the clamping of the specimen block is secure, meaning the XY orientation knobs are secured and the clamping lever is locked in an upright position. The block should be clamped well in the clamp, and no movement should be allowed. The orientation of the specimen head should also be in an upright, optimal position, centered, straight vertically, and even horizontally. The HM355S-3 microtome has a center lock position which can be observed when the orientation knobs click into place. Loosen the clamping lever and adjust as necessary so that the block face is parallel to the blade edge. Next, make sure that all the clamping levers are secure on the blade holder. The clearance angle should be set at 10 degrees on the HM355S microtomes. Secure the disposable blade in place by adjusting the clamping lever to finger tightness. Do not over-tighten this lever. This will only lead to excessive wear on the pressure bar. There are many factors that could result in microtomy issues with formalin-fixed, paraffin-embedded tissues outside of the microtome and accessories themselves. Poor tissue processing will lead to difficulty sectioning. When specimens are underprocessed, the tissues will usually be soft and spongy. Underprocessed tissues may separate from the paraffin or explode on the water bath. Overprocessed or dry, brittle tissues will shred or crumble when cut. Usually, over-dehydrated tissues are soaked on ice longer to enable the end user to achieve a usable section. When the tissues are overhydrated on ice, sections will stain light or splotchy. This is not a microtomy issue. Proper sectioning can be effected when the end user rotates the hand wheel too fast or rotates the hand wheel inconsistently. A steady rotation at a slower speed is recommended, especially for hard-to-cut specimens. Motorized cutting, if used correctly, can help with poor technique. Thick-thin, Venetian blind, and chunking can all be related cutting issues. We will discuss the service remedies as a group after user identification of these issues. Thick-thin, user. First and foremost, check the clearance angle. Consistent thick-thin, where inside of one ribbon there is a thick section, then a thin section, then a thick section, usually can be resolved through the clearance angle adjustment. An angle which is too slight or too high can result in thick-thin. Sometimes the microtome may skip a section or two and then cut a thicker section. This is also thick-thin and indicates that the angle is very extreme. Thick-thin is usually seen at the microtome or on the water bath, but sometimes can be only visible on the stained slide. Dense, hard tissue, such as uterus or bone, is most susceptible to thick-thin and usually has nothing to do with a microtome. For best sectioning of these types of tissues, the block must be cut slowly and consistently. Fast cutting will enhance the problem and potentially could pull the tissue out of the block. A harder embedding wax is usually better to support these types of tissues, and, of course, proper processing and decalcification, if indicated, is required. If adjustment of the clearance angle does not alleviate the thick-thin, make sure all clamping is tight. If these two solutions do not improve the sectioning, service will be required. Venetian blind, user. Venetian blind or chatter is similar to thick-thin, but the unevenness occurs within the same section. This artifact is sometimes referred to as washboarding because the section will look undulated like a washboard. Some hard, dense tissues like uterus or bone are more prone to Venetian blind as they present more force all at once on the blade edge. Embedding tissues on edge with a diagonal orientation may help with sectioning as well as cutting with a slow, consistent speed. Poor processing can lead to Venetian blind as well. Even tight clamping of the blade is crucial to avoid this artifact. Loose or worn parts on the blade carrier or specimen clamp may also result in Venetian blind. If this artifact only occurs on specific tissues that are known to be hard or dense, then the microtome most likely is not to blame for the condition of the section. Better processing and embedding technique may be required. If this artifact appears on all kinds of tissue, check the clamping on the blade holder to ensure it is secure. If you find the closure on the clamping plate to be uneven, service may be required. Chunking, user. When the tissue is pulled out of the cassette block during sectioning, this is referred to as chunking. Improper techniques such as rotating the hand wheel too fast during sectioning or trimming the block at a higher thickness while cutting quickly may lead to the specimen being pulled out of the block. Inadequate processing can also add to the issue. The user should reduce cutting speed and ensure that the tissue is processed adequately. If these conditions are met and the unit is continually chunking, service will be required. Thick-thin, Venetian blind, chunking. Service. The following are mechanical issues that could contribute to these 3 cutting concerns. Inadequate clamping of the blade in the blade holder may mean the holder needs to be replaced. Worn levers that do not stay tightened may be repairable or also replaced. A bad universal cassette clamp may not secure the block well, possibly due to bad springs, in which case the spring should be replaced. Try these remedies if thick-thin or Venetian blind is the complaint. If chunking or thick-thin is an issue, inaccurate microtome advancement could be the cause. Check and confirm this with a dial gauge. Or, if the setting arm torque is not between 350 and 400 gram-pounds, then the spindle and nut need to be realigned. This procedure will be covered in detail later. With Venetian blind complaints, check the UCC and blade holder for cleanliness. So, the remedy could range from cleaning to replacing parts. Compression. User. Compression or bunching of the condensed section at the knife edge usually is due to the block face being too warm, the paraffin being too soft, or a dull blade edge. Cooling the block longer and/or replacing the blade usually will fix the issue. Sectioning at a high rate of speed also adds to compression. Very thin sectioning is usually more susceptible to compression. If a slower, consistent speed on an adequately cooled block with a new blade does not improve the sectioning, service will be required. Compression. Service. Check to see if the clamping plate of the blade holder is not milled correctly or is too short or long, which would require replacement. If the setting arm torque is not between 350 and 400 gram-pounds, then the spindle and nut need to be realigned. Knife marks. User. Knife marks that occur with a new blade and extend all the way through the block face can be due to a bad blade or a nick in the front or back clamping plate. Firstly, inspect the block surface. Some tissues may have calcified inclusions, bone, staples, or sutures included, which will lead to knife marks. Usually, during the initial cuts, the knife marks may only be seen halfway through the block beginning at the point of the inclusion. As the section is cut deeper, the line or split will continue throughout the whole ribbon. If the block looks unaffected, try a new blade. Within a few sections, the lines should clear themselves. If they do not clear, then most likely you have a nick in the clamping plate that is causing the line. This can occur from previous sectioning of blocks with artifacts, from forceps being caught on the clamping plate when trying to section, from the specimen head coming down upon the blade edge, or if the blade holder may have been dropped. Multiple lines in one block may be due to an inadequate blade edge, or if the paraffin used for embedding has been contaminated or is gritty. A new blade should fix the issue. Knife marks. Service. If knife marks are observed during sectioning, visually inspect the front and/or back clamping plate of the blade holder. If damaged, affected parts should be replaced. This concludes the lesson on cutting basics and how cutting issues could occur. We now turn to a brief lesson on the operation of our manual rotary microtome, the HM325. Thermoscientific HM325 Manual Rotary Microtome, Basic Operation. The HM325 is a manual rotary microtome that can cut sections up to 60 microns. With no electronics, the HM325 microtome with selectable retraction, trim key, and section counter is a good alternative for a quality microtome without all the bells and whistles. The ergonomically weighted flywheel can be locked in any position via the mechanical brake. The thickness setting can be adjusted up to 60 microns via a dial knob. A battery-operated section counter will track how many rotations of the hand wheel have occurred. An audible alarm bell is activated when the specimen head is at the front end position. Cutting beyond this position is not recommended and could damage the microtome. The HM325 microtome now has an on-off selection for retraction, enabling the end user to rock the hand wheel in a forward position between the 12 and 6 o'clock position of the hand wheel without affecting the microtome itself. This option was made available due to the discontinuation of the HM310 and HM315 versions, which did not have retraction. Although not an ergonomically preferred method of trimming, with retraction off, the specimen head will advance the set thickness to face the block. If the end users trim and section each block one at a time, turning retraction off should alleviate the issue of the specimen head jumping forward and chunking the block face. A more preferred method of facing on the HM325 microtome is to use the trim lever underneath the coarse flywheel. If the trim key is depressed slightly when rotating the hand wheel, the HM325 will advance at 10 microns each stroke. If the trim lever is depressed all the way, the specimen head will advance at 30 microns. Once the trim key is released, the specimen is advanced at the specified cutting thickness. HM325 microtome. Manufacturer service tips. What follows now are service techniques recommended for the HM325 microtome. Spindle and nut alignment. Whenever removing or replacing the spindle and nut, the main component of the micrometer mechanism, a spindle and nut alignment must be done. The spindle and nut will need to be realigned after any service, including preventative maintenance. Symptoms of a misaligned spindle and nut are sectioning performance issues, including thick-thin and skipping sections, where the machine totally misses a cut. To conduct a spindle and nut alignment, the first step is to remove the cover. Refer to Section 9-6 in the HM325 Microtome Service Manual for a complete description of the removal of the cover. Refer to Section 9-11 of the HM325 Microtome Service Manual, Micrometer Mechanism, for a complete description of the disassembly and reassembly of the micrometer mechanism. When tightening the 4 screws to the bearing disc, it is important that you simultaneously are turning the micrometer nut tool. This will ensure that the spindle is centered in the bearing disc. As you turn the micrometer nut tool, tighten the 4 screws on the bearing disc in a crisscross manner. This will help assure that the spindle is centered in the bearing disc. Doing so will result in the proper torque. Then install the setting arm and the toothed wheel along with a threaded bush. Remove the rearmost 4 mm screw on the bottom side of the extension arm and only loosen the front 4 mm screw enough to where the gears are separated. Using the spring scale, assure that you have a value between 350 grams and 400 grams of torque on the setting arm, discussed in Section 9-11-1 of the HM325 Microtome Service Manual. If the required torque value is not achieved, clean all the parts in the micrometer mechanism, lubricate, and reassemble. Check the torque again. If the required torque still is not achieved, replace or clean the setting arm. Replacement could be required if the 3 rollers inside of the setting arm have flat spots on them. After achieving the required torque setting, install the coarse feed hand wheel and turn as you tighten the 2 4 mm screws to the extension arm, making sure the gears do not bind, which could cause wear, but operate smoothly. This completes the spindle and nut alignment. We now turn to a lesson on the operation of our HM355S-3, an automatic rotary microtome. HM355S-3, microtome, basic operation, buttons. The HM355S-3 is an electronic, fully motorized microtome, which can also be used for manual sectioning. The removable control panel has 3 knobs on the left side of the control panel. The buttons may be used as follows. Top knob, fine trim selection. Push in to switch between fine and trim section thickness. Rotate the knob to change the setting. It is also used in the menu option to scroll through the list and depress the button to select the option. Middle knob, coarse feed knob, activates the electronic advance of the specimen head both forwards and backwards. 3 speeds are available. The farther you turn the knob, the faster the electronic movement. When depressed, the coarse feed knob also functions as the trim key, advancing the specimen head by the trim thickness setting. Test by scrolling to remaining travel to make sure it is advancing properly. The remaining travel is in microns, with the front end position as 0 and the rear end position as 28,000. The trim key can be useful in the initial trimming of the block as an alternative to rocking the handwheel. Bottom knob, speed and start-stop. Rotate to change the speed of the motorized cutting during the cutting window. This speed is indicated as V equal on the display screen. Double-click the knob to start motorized cutting and single-click to stop the motorized cutting. Starting with the operator functions of the control panel, we will now cover each button and its function. Menu button. Scroll through options by rotating the top knob. To choose option, depress the knob and also depress to confirm selection. Mode. Motorized sectioning mode. There are 4 settings. Continuous. Specimen head continues cutting until you stop via the start-stop button, brake option, or foot pedal. Single. Specimen head cuts 1 complete section and then stops in the uppermost position or when the flywheel is at the 12 o'clock position. Multi. A selectable cutting option from 2 to 99 where a specific number of sections can be programmed to be cut. Useful for serial sectioning of small specimens. Interval. The specimen head will continue through the stroke while the start-stop button is depressed. When released, the stroke ends. Automatic V reduction refers to the speed of the motorized cutting during the cutting window when switching from trim to fine thickness. Typically, fine sectioning is performed at lower speeds to achieve better sections. The motorized cutting speed is indicated on the display in the middle of the bottom information line as V equal the speed. This speed does not affect the return upstroke, which is always increased for better efficiency during retraction. With automatic V reduction, the speed is reduced a specific percentage when switching from trim to fine thickness. When 100% is selected, the motorized cutting speed inside the cutting window stays the same when switching back and forth from fine and trim. Display mode. Normal, with specific cutting information shown, or large, which just shows the selected section thickness. Retraction, on-off. Retraction can be turned off if desired. Retraction is the safety distance wherein the specimen head is allowed to retract during the upstroke of the cutting motion to avoid contact with the blade edge or specimen. Language. Time and date. Factory defaults. Service menu. protected by key presses for service personnel only. All of the functions we have just discussed can be found by utilizing the menu button. To exit the menu function, hit the menu button again. The middle button is your scroll function. This button will scroll through the information in the middle line of the display. Counter equal number of sections cut. Step sum is the total of microns cut. Remaining travel, 0 to 28,000, the amount of cutting room the specimen has before it reaches the front end position. Time, date. The reset button is the third button on the top row. Use this to reset any counter. Display. Here is what is displayed on each line. The top line, section thicknesses. The middle line scrolls through sectioning information. The bottom line. On the left is the motorized cutting mode. In the middle is the speed of motorized cutting. On the right is MEM if memory position is stored. LEDs under display. Up and down arrow LEDs. When flashing, indicates the front and back end positions of the specimen head electronic movement. Retraction LED. Lights up when the specimen head is in retraction, typically between the 6 o'clock and 12 o'clock position of the hand wheel handle. Middle row of control panel buttons. Hand wheel brake. Can be activated manually in manual or motorized sectioning. Also comes on automatically at the stop of each motorized cutting selection. Cutting window button. Sets the parameters for the cutting window of the block, during which the speed of the motorized cutting can be controlled. On microtomes with motorized cutting, this function enables the end user to adjust the cutting speed to the size of the block, which will produce the optimal section. Typically, these parameters are set at the upper and lower edge of the paraffin block. To set the cutting window, rotate the hand wheel so that the lower edge of the block is slightly above the blade edge. Briefly depress the cutting window button. Continue rotating the hand wheel so that the upper edge of the block is slightly below the blade edge, and depress the cutting window button again. To confirm setting, rotate the hand wheel a few times. The LED should be illuminated when the block is within the cutting window. Memo button. Memory function where a position during the electronic travel can be stored for easy return of the specimen head near the first cut position. To store a position, press and hold the button until you see Memory POS Saved on the bottom of the display. When MEM is displayed on the screen, press the Memo button briefly, and the specimen head will return to the stored position. Bottom row of control panel buttons. Start-stop. Activates motorized cutting. Depress twice to start motorized cutting. Press once to stop cutting. Specimen head will return to uppermost position, 12 o'clock. The hand wheel brake is automatically applied when the stroke is finished. Mode. Scrolls through the motorized cutting modes as indicated on the lower left of the display screen. Also can be set in the menu function. Rock button. Engage if user wants to rock the hand wheel during trimming or facing the blocks. We do not recommend rocking as the motion is not ergonomically friendly, but many end users prefer this option. Rocking refers to only using a forward partial rotation of the hand wheel to quickly face or trim the block edge preparing for sectioning. When only using this partial area for cutting, once the hand wheel is fully rotated, the specimen head will leap into the block, causing chunking. With the rock button activated, the specimen head will advance in the forward position, not in the 12 o'clock position used for normal cutting. Besides the handwheel brake, the HM355S Microtome has 2 additional brakes for safety purposes. The red button on the front right side of the housing is the emergency stop brake. When this brake is applied, the motorized cutting is immediately stopped. The handwheel can still be turned with this brake applied, but only with tension. When the Microtome is not in use, it is best to apply the hard stop brake, which is located under the handwheel. This mechanical brake lever will not allow the flywheel to move without being released. It can be locked in any position. Both the emergency brake and hard stop brake are indicated on the control panel display with a stop sign icon. Servicing the HM355S-3 Microtome. After identifying the problem, whether it is chunking, thick-thin, or Venetian blind, etc., from a service standpoint, we would check the advancement and retraction of the cylinder via a dial and a dial gauge holder. From an electronic standpoint, we could verify proper voltages to and from the CPU and resistance values from the stepper motor. If these steps are confirmed, the next logical action would be to clean the micrometer assembly. Steps for cleaning and maintaining working parts. The following tips are recommendations from the manufacturer. The cleaning procedure for the micrometer mechanism. Remove all parts from the micrometer mechanism, including the cylinder and the 2 guide wedges. Using a toothbrush and a cleaner, preferably citrus solvent, clean the parts. Rinse in alcohol and thoroughly dry them. Lubricate all parts with Microtome oil. It is important to make sure there is a 3 mm gap between the micrometer nut and the counter nut. If you don't have the 3 mm gap, you will have backlash, meaning there is some play within the micrometer mechanism. Cleaning and maintaining the slide segment for the link block. Refer to Service Manual Section 9-8 and follow the procedure to remove the shaft with bearing. Remove the link block. Remove all the old grease from the slide segment and the link block. Apply new low-soid grease to the slide segment and the link block. As detailed in Service Bulletin 2008-03, using the spring scale, position it against the link block and slide the link block back and forth. Note the torque value, which should be in the range of 80 to 125 centinewton meters. If the torque value is higher or lower than this range, the link block must be replaced. Adjusting and cleaning the linear pot on the HM355S-3. This procedure is unique to the HM355S-3, as it is the only instrument with this particular part. Remove the housing of the instrument, but replace the handwheel so that you are able to lock the handwheel brake in the position where the contacts are centered on the linear potentiometer board. Remove the ribbon cable to the linear potentiometer board, then remove the 2 3 mm screws that attach the contacts to the instrument. Visually inspect the contacts. If they look bent or worn, then the contacts should be replaced. Refer to Chapter 9, Handwheel Potentiometer section of the HM355S-3 Service Manual. Use a soft cloth with alcohol and clean the linear potentiometer board. Then, reinstall the contacts. But before tightening the screws, you must use the supplied distance tool to achieve the proper distance between the contacts and the linear potentiometer board. Finally, reinstall the ribbon cable. The procedure for adjusting and cleaning the linear pot is now complete. Using thermoscientific Microtome specialty tools, we now turn to a series of demonstrations of the proper use of Microtome specialty tools for thermoscientific microtomes. The following tools are used on the HM325 microtome. 4-way socket wrench for the threaded bush is used to remove the threaded bush. Spring scale is used to measure the force required to move an object. Key for micrometer nut, HM325, is used to remove the micrometer nut. Spring scale for link block, used to measure the force on the link block. Dial gauge is used to measure the advancement and retraction of the cylinder. Dial gauge holder is used to hold the dial gauge. Torque wrench is used to measure torque on a nut, screw, bolt, etc. Adjustable spanner wrench is used to remove various parts. Torque measurement device for the micrometer spindle is used to measure the torque needed to move the spindle. The following tools are used on the HM355S-3 microtome. Micrometer nut tool is used to remove the spindle and nut assembly on electronic microtomes. Interlock plug, a tool used to simulate a foot switch in place. Dial gauge is used to measure the advancement and retraction of the cylinder. Dial gauge holder is used to hold the dial gauge. Torque wrench is used to measure torque on a nut, screw, bolt, etc. Adjustable spanner wrench is used to remove various parts. Torque measurement device for the micrometer spindle is used to measure the torque needed to move the spindle. Spring scale for link block, used to measure the force on the link block. We have just reviewed lessons on the use, maintenance, and service of two popular rotary microtomes, the HM325 and HM355S-3 models. In addition, cutting basics and issues were discussed in detail. For further instruction on the service or maintenance of these rotary microtomes, please refer to the latest service manuals for the HM325 or HM355S-3 microtomes.